Hello, students. Welcome. Today, we're going to explore a really fundamental concept in chemistry, the three states of matter. Have you ever really thought about the world around you? Why is the desk you're sitting at solid, while the water you drink flows, and the air you breathe is, well, everywhere? Let's find out together.
So let's start with a simple question. Why is it that a book is hard and keeps its shape, but water, it just flows and takes the shape of whatever glass you pour it into? And what about the air we breathe? It's all around us, but we can't see it. What is the secret behind these very different behaviors?
The answer to all these questions lies in a world we can't see with our naked eyes. If we could zoom in, really zoom in on everything, we would see that it is all made of tiny, constantly moving particles. How these little particles are arranged and how they interact with each other, that is the secret that determines everything.
So, here is our plan for this explainer. First, we'll look closely at what these tiny particles are like. Then we will dive into the solid, liquid, and gaseous states, one by one. And finally, we will bring it all together with a simple comparison to make sure everything is absolutely crystal clear. So, let us begin.
Okay, first section. What is matter really made of? Let's try to understand the basic rules that these tiny particles follow. Now, this part is very important, so please listen carefully. All particles of matter have three key characteristics. First, they have space between them. Second, they are always moving. They never stop. And third, they attract each other. Please keep these three rules in your mind because the entire story of solids, liquids, and gases depends on them.
And now for our second section, the solid state. Let us see how our three rules apply here. Just think about any solid object around you right now. Your pen, your book, or maybe the desk you're sitting at.
Solids have some very clear properties, don't they? They have a definite shape and a fixed volume. A book doesn't just change its shape, right? They are also rigid, which means they resist being bent or squashed. And because of this, they have what we call negligible compressibility. You can't really squeeze them into a smaller space. So, the question is, why do solids behave this way? Let's look at their particles. You can see how they are packed so tightly together in a very neat and orderly way. The force of attraction between them is extremely strong, and this force holds them in fixed positions. Now, they are still moving because all particles move, but here they can only vibrate in their own place. This strong bond and fixed structure is what gives a solid its strength and its definite shape.
But wait a minute, I know some of you might be thinking, "Sir, what about a rubber band? We can change its shape. And what about a sponge? We can compress it. Are they still solids?" Well, these are excellent questions. The answer is yes, they are, and the reason is quite interesting. You see, with a rubber band, it changes shape only when you apply force. The moment you release that force, it comes back to its original shape. If you pull too hard, it will break, but the solid itself does not flow. Now, in the case of a sponge, it has tiny pores, tiny holes, which are filled with air. When you press it, the air is pushed out. So you see, you're not compressing the solid part of the sponge, but the gas that is trapped inside.
Okay, so that was solids. Moving on to our third section, the liquid state. We all know what liquids are, things like water or juice or milk. Let's see how their particles behave differently.
Now, here's the key difference from solids. Liquids have no fixed shape. They take the shape of whatever container you put them in. But, and this is very important to remember, they do have a fixed volume. 1 liter of water will remain 1 liter, whether it is in a tall bottle or a wide bowl.
So why can liquids flow? Let's go back to the particle level again. The particles in a liquid are still quite close to each other, but the force of attraction between them is weaker than in a solid. This allows them to break free from their fixed positions and just slide past one another. It is this sliding movement of particles that we call fluidity, or what we simply see as flow.
This constant movement of particles in liquids leads to a very fascinating phenomenon called diffusion. This is the process where particles of two different substances mix into each other all on their own, simply because they are moving around and have spaces to move into.
And you know, diffusion is absolutely essential for life. For example, oxygen from the air diffuses and dissolves into the water of lakes and rivers, and it is this dissolved oxygen that aquatic animals, like fish, are able to breathe. So in a way, it is diffusion that makes life underwater possible.
And that brings us to our fourth section, the gaseous state. The best example, of course, is the air all around us. Let's see what makes gases so unique.
Gases are in a world of their own, completely different from solids and liquids.
They have neither a fixed shape nor a fixed volume. A gas will simply expand to fill the entire space of any container you put it in, and their most defining property is that they are highly compressible.
And the reason for this behavior is very clear when you look at the particles. They are extremely far apart from each other. The space between them is huge, and the force of attraction is almost zero, negligible. This freedom allows them to move randomly and at very, very high speeds in all directions.
You see a very practical application of this in your kitchen every day: the cooking gas, or LPG cylinder. A very large volume of gas is compressed and squeezed into that small cylinder. This is only possible because of the huge amount of empty space between the gas particles that can be reduced.
Now, because these particles are moving so fast, they are constantly hitting each other and also hitting the walls of the container. This continuous hitting exerts a force on the walls, and the force exerted per unit of area is what we call gas pressure. This pressure is what keeps a balloon inflated.
Okay, let's move to our final section and put everything we have learned together. Comparing the three states side by side will really help to make the concepts clear, and this is also very useful for your exams.
This table gives us a perfect summary. Please notice the clear trend as we move from solid to liquid to gas. The space between particles goes from minimum to moderate to maximum, and just the opposite. The force of attraction goes from maximum to moderate to minimum. These two properties, the space and the attraction force, are the key to explaining everything else.
So here is the most important takeaway from today's lesson. Everything that we see and feel about solids, liquids, and gases, their shape, their volume, their ability to be compressed, it is all a direct result of what is happening in the invisible, microscopic world of particles. The big picture is determined by the tiny detail.
And this leaves us with a final, very interesting question. If the state of matter is all about how the particles are arranged and how much energy they have, what happens if we change that energy? For example, what happens if we heat a solid or cool down a gas? Can matter change its state? Well, that is a topic we will explore in our next explainer. See you then.